How can you get your private code never seen by these large AI models, into systems like Cursor so that you can get appropriate code suggestions back without sacrificing your privacy? Someone recently asked me this great question. How do AI coding tools like Cursor AI get context to your private components so that they can suggest appropriate snippets? Without this context, they won't provide any reasonable suggestions and thus are not nearly as meaningful. But the question is, how much context do you have to give? How much security do you have to risk? I didn't have an answer, so I decided to build an experimentation engine that could take different sets of context for these different private components and send them through a prompt system, get suggestions back, and then send those suggestions with all of the information into an evaluator that could then judge the answer and give us a consistent scoring system back to say which version of sets of files is the best or is maybe the least amount of context to get the highest value that you're willing to sacrifice. Today I'll show you exactly how I built that. We're in fact going to go and rebuild it entirely from the ground up. Fun fact, we're going to use vibe coding to do it, because I do believe that you can use vibe coding to build sophisticated systems. This, in the end, is a very open-ended, configurable experimentation system that can do evaluations of responses from LLMs. Let's dive in. Okay, we're going to start where all great things start, Cursor. Some of this, to be fair, is educated from the fact that I've already built this. What we're going to build, though, is going to be a Python system. First thing I'm going to do is create a new project. Your agent will probably be set, if you're using this, if you're following along, will probably be set to auto-select. That's perfectly fine typically. I will say there is an open question of when do you use the thinking model? When I'm starting up with a project, very frequently, I will start with a thinking model to begin with and say, I need you to design something that does, and you'll hear me blather along as you guys have heard before. And the thinking model will first congeal that into an initial pre-plan, and you might be able to see that in the thinking as it passes by. Then it will turn that into a very discrete plan, and you'll see the discrete plan it comes up with is much shorter than even the blathering that I do generally. And that will end up being the plan that it actions on. I'll let it go build it, and we'll go on from there. Hey Cursor, listen, today we're gonna build something fun. I'm going to build something here in Python, and I want us to build a system that is well organized, follows our typical separation of concerns, keeps things apart, don't pile a whole bunch of things into one file if you can help it. That separation, I think, will help us keep things clear. Later, we will be building LLM integrations, so we'll be using OpenAI to begin with, but I don't want you to become opinionated with things like that. I want abstractions. So I want you to be able to utilize different intelligence systems where we want to supplant and move to a different provider. We will also need to be configuring the system. One of the major documents in this system will be a config document that's written in YAML that the customer will create. Our first pass, though, I think I need a system that can read these config files and just let's print them out to the screen first. The way I think we should separate our code is there should be a source folder and an experiments folder, and those should both be maybe top-level folders. The experiments folder is going to be something that we have subfolders in, and the first experiment might be called sample, so feel free to create one called sample. In that file will be our config, so it'll be config.yaml inside of that file. So now what we're going to need to do is have a main that kicks up, reads that YAML, and spits it back out to the console, something that simple. Let's kind of start with that. Okay. That's a whole lot. I did a couple things here that are worth noting, just in case. I told it about separation of concerns, told it about creating kind of a plan, and also gave it an idea of a file structure, so where it might be putting things together. And there was also a magic word in there, which is abstraction. You don't have to have done that. Later, you can come back and tear back out. If it just did OpenAI, you could then say, I'm going to need to use other providers. It's pretty good at backing that kind of stuff off. But if you give it the concept it needs to do separations and abstractions, it will architect a little bit different from the beginning. And this beginning step is kind of foundational to everything else you do. So other systems, other requests that you put in will look at the architecture you have and solve it with that puzzle. And away we go. Okay, and it concluded. It wrote the files that it needed. If we look into its source, you can see it built a base LLM mechanism. Inside of the config, it has the ability, the mechanism to read the environment in, as well as load the config files that we were talking about. And then inside of source itself, it created the sample and a sample config file in there. All very good. It actually, if you look back up a little bit, yeah, so it goes through the process here of actually executing what it's written and checking the feedback. and then saying, okay, this is what else we might need to do, runs it again here, and then now you can start seeing this come out. So it has this mechanism to be able to look and print the configs like we asked it to, and then it comes back and says, score. Okay, Cursor, the next thing we want to do with this project, it's a brand new project. What I'm going to need is to focus you on the experiments folder. You'll see inside of there is a subfolder called sample. There will be a subfolder per experiment, just so that you're aware of what's going on here. We're going to work inside of the sample for now. What we're going to anticipate is that inside of each one of these experiment folders, there will be a data folder. So feel free to create a data folder that we will hold down from our system versus the code that it found on the internet or it hallucinated it. So let's start off with just one simple file. Let's make it a TypeScript file that is this Jack carousel that has some kind of complicated set of features, not overly complicated. We really want it in one file if you can keep it in there. Okay, I understand that was a weird one. All I'm really doing is setting up our sample data. So the project that I have here is saying if there's private code that is only in our world, how much do we need to give to some context for it to be able to return that private code or for us to be able to code with it appropriately? And to do that, I really need some constructed code, something that is very unique to only us. So that's what we're really creating here. Doesn't matter if it works, doesn't matter if it's good. In fact, of course, I want it a little bit obscure. Okay, so I have the documents in place. The next step we're gonna do though is we need to get the rest of this config built so that we know how to build up the different experiments that we need. So let's take that on next. Okay, chat, let's give this a shot. I need to edit this config YAML a little bit. What I'm going to need is an experiments block. That experiments block will be an array of other objects. Those objects will have things like the file set, and the file set will be an array of file names, if that makes sense. So essentially, okay, here we are at the first moment that's actually kind of interesting compared to running in a web system. So I wanted to show you this. It's telling me, okay, we've gotten to this point. We're building the document reader, blah, blah, blah. Nothing you need to necessarily worry about. We're just trying to read in the file and print it back out. But what it's saying is, here's what you can do. You can now run the program with this command. So what I'm going to tell it is, please run it. And you'll see that it ran the program. There's an error in the program. It sees the error. It comes back and says, oh, I see that there's a problem. Let me run the program again. Fix it, run the program, and it goes through this cycle until it gets it fixed. Very, very cool to watch it happen. Okay, so far, pretty good. So what I've asked it to do is to create a templates folder and a sample template. So if I run it, what we see here is, here's the experiment, sample experiment 1. This is all from the config. That's the configuration. The document set here is the files that it's reading, and this is the contents of that file. Okay, so at this point, it knows how to read the config, it knows how to load the files, and replace a template. That's really the majority of what we have to do here. Right now, we're going to add some AI stuff to it, some LLM work to it, to take in a prompt, send that prompt off, and get the results back and print it out. So we'll do one LLM aspect at a time. Okay, Cursor, let's get on it. It's time to do some LLM stuff. Again, I'm going to use my environment variables to put my OpenAPI key in so that you can make these requests, but I want to make an OpenAPI request that uses the prompt request inside of our config. So I want every time that we run an experiment to use prompt request. This step, what we're looking to do is just take the config value of prompt request, pass it to OpenAI using the properties that you see in the config, and get the response back and print that out. Can you do that? Feel free to do pip install and then run to see if this works. Okay, it tried to run it. It says error during generation. So it's going through and looking at what it needs to do. Okay, and it ran, and what did we get back from say hello? It says, hello world, how can I assist you? So that's success. So I'm gonna run experimenter sample, and it goes, talks to the LLM, gets back hello world. All right, Cursor, I am interested in cleaning up our logging. I want some very clean run logs. I like color-coded logs. I like emoji as a kind of an icon for the different types of logging so that I can tell the difference between the messages. But what I want logged is when we execute a config, or really when we run an experiment, I want to print out the name of the experiment or the name of the project itself and the description of the project. And then each experiment that you run, I want us to kind of write out enough information so that we can see what's executing. But let's get colorful. So this is a space you live. You may as well enjoy it. All right, let's see how it did. And what do we think? I like it. It's at least cleaner. All right, Cursor, we're taking a big one. This hopefully is roughly the last major step. If you recall, we have a project folder. That folder currently is sample, which is inside of the experiments folder. We also want to have the results as a folder. So it should be sample with subfolders of data, templates, and results. Inside of the results is where we will save the results of all of the experiments that are executed per run. Then inside of that folder is where we will write result files. So we'll be using the output.md file or template, and it's a template again, so that you'll have to replace things in it. That will describe the output string that you want to save as an MD into this results subfolder. Inside of the subfolder, you should use the snake case version. So kind of turn the name of the experiment into a file name, .md. So that's what we're looking to create. Oh, this is looking great. Okay, this is fantastic. That was a great single swing to get to this. Now we have literally just one last thing to ask it to do. Okay, I've been telling you I was going to do this for a while, and really it's risky on my own part. I'm just so focused on moving forward. Come over to your source control object here. If people haven't done this in the past, you can initialize a repository, which just creates a local on your hard drive Git repository. Essentially what I'm doing is creating kind of time capsules. Hey, at this moment in time, I want to save everything. At this moment of time, I want to save everything. And what we'll see down here is a time capsule that we might be able to roll back to. Initial commit. As you make changes, you can just come in here, generate a commit, save it. All right, so we're at that last step. Here we are. We've got everything except we need to call with what we have back to evaluate. Okay, we're finally here, Cursor. This is what I need you to do. This should be pretty easy because we have a pattern to follow. We are now going to send off another LLM request that uses our prompt evaluation template. And I think that prompt evaluation template has already been exercised. We've kind of made sure that it runs. So what we need is the information from that prompt evaluation sent off into the next LLM request, and the data that comes back from it is, I believe, evaluation response or something like that. Once we have that, we should be able to fill that in on our templates just fine, and we should then start seeing scores. Oh my God, I'm in a runaway. I've never seen this one. I can't get it to stop no matter what I do. I can't get Cursor to stop. Yeah, stop. No, it's good. Stop. It makes changes. It makes changes. Oh, this is killing me. Stop. Cancel. Stop. Okay, I'm stopping. Not stopping. And it keeps running. Oh, this is driving me bananas. Okay. Oh, stop. No, stop. Stop. Ah. Oh my God. Okay, Cursor. Help. All right, I'm going to have to quit Cursor. This is ridiculous. No, I need you to, no, I need you to stop. I need you to stop making changes, really, is what I need you to stop doing. Stop, Cursor, stop. Give me a bigger stop button. No, stop. Oh man, you're gonna change everything. All right, hang on, I gotta go. Okay, so I had to hammer Cursor. Hopefully that took care of it. Before I accept anything, what I'm gonna do is I'm going to run this one time and see what we get. Because I think we're done, or really almost done. So let's take a quick look and say, we're gonna run the experimenter. So now what we're basically doing is we're taking that response from the first one and then sending all the documents as well as the response and asking, hey, this is the response we got back. How well does it match all of the requirements that you have for the evaluation statement? So the evaluation statement is saying, ooh, make sure that these critical items are in there. Make sure it absolutely tells you this. If it misses any of these things, the score has to be bumped down, that kind of stuff. So it's really using the LLM as the evaluator on the second half. So what do we get? Overview, how close can we get to a meaningful description? So it's only using the TypeScript definition file, and it got to a 70% evaluation with just the TypeScript definition file. The things that it met, requirements except for critical data success, the Jack data callback is missing. Okay, that's interesting. Accessibility labels and roles are correctly defined. It says Jack data callback is missing. The implementation must have either Jack items or Jack data callback, and while Jack items is present, the absence of Jack data callback is a critical failure. This actually, that one little detail is what Cursor kept reading in the result file, saying, wait, but that should be okay. Let me update the prompt. It should be okay if you get one of these back. So it's kind of funny that it's still in there. And I would say this is not a failure. It is defined, as it's even saying, having one is just fine, but having missing the other one is a critical failure. So I think our evaluator needs to be updated to make sure that we're sending in a prompt that makes sense from the LLM standpoint. And frankly, at this point, I might move over to something like the playground in OpenAI or something like that, and start posting these in and changing the prompt to see what responses I get, what the differences are. That's very, very helpful when you're doing prompt engineering, that you can kind of turn it around very quickly rather than running your whole system. So this sounds like at least an 80-85% detailed analysis. So this is great, and this is actually the results. So this is what we got back from the response. This is the kind of thing that you would, if you asked, hey, tell me something about a tool that knows how to do carousel of images, this is the kind of information that you'd get back, which seems really complete when you think it's just coming from a TypeScript types file. But I'm still blown away with how many changes this thing went through. And now, of course, the idea is very simply that we would come in here and say, let's run 2 experiments. I'm sorry, I think I'm shell-shocked. Let's use just the documentation. So the Jack Carousel MD is that simple documentation. Now we can run both of these. Here we go. This is it. This is the big moment. All right, it's going out. It's doing the types only experiment first, and now it's doing the documentation experiment. It wrote the types experiment results here and running the evaluation, and we have the documentation. So types only, let's get rid of that. Types only gives us, we believe, probably that 70% again. Yep, types only comes back as 70%, but documentation only comes back as 75%. Now, admittedly, I have to change the prompt to get the right values back from this stuff. So it would be interesting to see which ones of these perform better. What mix of them perform better. This is exactly the experimentation that I was doing to try to figure out, if I just send in the types, is that enough documentation? And frankly, to give you a spoiler, without having to go through that and drag you through that headache, it is. A well done types file is actually pretty good. It gets you about to 80%, maybe 85%. To me, a 90% is defined as almost nothing extra would ever be needed. And if you've ever used any code completion tool, it doesn't always give you all the properties and give you enough education about all the different moving parts. So an 80% feels like a very usable system that might really work. Okay. Okay, so that one was fun. A lot twistier than it was the first build, but that is vibe coding at its essence. So the finding here basically is, sure, obviously you can use vibe coding as much as it seems like that exploded on me. The reality is this is a really good system, as you saw. Adding another set of experimentation was very simple. It's very extensible, but if I was writing it by hand, it would have taken easily 10 times longer. If this looked like, hey, wait, I need to do that, I have 2 pieces of advice. One, if you're using Cursor and a couple other tools right now, is MCP. I have a couple other videos, not surprisingly, about MCP. It's just this mechanism to allow for an intelligent system to use tools. This could be your tool, right? You could absolutely have an MCP that pulls in all of your important types files or something like that. You could rag it if you only want to pull in certain parts of it, or if you could condense it enough that you could just slam it all into context window when you need it, and you could say, using my personal information, and that could be the hook to call that MCP tool. It'll pull all of it back, drop it into your context, and you're off and running. So that's really one way to move forward with this. The other way to move forward with it that I see is actually building kind of a package of information or a package of documentation that you might pull into your project. So if you're really in a very private environment, then you would be able to just pull these files into Cursor itself, which indexes the project that it's sitting on. Those are the current best practices that I see. There's ways to also take these files if you're in an enterprise or some kind of company GitHub, local GitHub, you might be able to put these types files into the GitHub enterprise environment that it will be able to fine tune and train on. So that's actually a very reasonable expectation if you're going to be using GitHub Copilot or something like that. Hopefully you got something out of this other than just laughing at me. Don't worry, I'm laughing at me too, perfectly fine. It was an entertaining day to try to wrestle this thing back into shape. So now I have two versions of the exact same application. I hope it was helpful to you. Thanks for coming along for the ride on this one, and I'll see you in the next one.